All right, welcome to your 7.7 notes. It's our last notes video in this Unit 7 on radicals. Today we'll be talking about solving radical equations and inequalities. And we'll start out with a simple word problem. So we have computer chips are made from the element silicon, which is found in sand. Suppose that a company that manufactures computer chips uses the formula C equals 10 times n to the 1/3 plus 1,500 to estimate the cost in dollars of producing n number of chips. So they're asking us what would the cost be to produce 2,700 chips? Well, we know n is our number of chips, and they're telling us that we have 2,700 chips. So n is equal to 2,700. And really, we're just placing this n value right into our equation. So what we're going to have is C equals to 10 times 2,700 to the 1/3 power plus 1,500. Right. So if you notice, we're taking 2,700 to the 1/3 power. We can also write this as 10 times the cube root of 2,700, and we're adding 1,500 to this. And the cube root of 2,700 is 30, so we really have 10 times 30 plus 1,500, and 10 times 30 is 300, and we have plus 1,500. So 300 plus 1,500 is going to give us 1,800. And this, since we're dealing with a word problem, we know we need to have units, or we need to have some sort of, I guess, units, you could say, behind this or on this. So what we're finding is the cost it would take. So we know that this is $1,800. All right, so moving on, what we're going to do today is we're going to be solving radical equations and inequalities, but more so in this notes video, we're going to be focusing on solving equations that deal, and we have these equal signs. We'll talk more about inequalities in class because we need to work with domains and such. So if we look at our first problem, we have the square root of x plus 1 plus 2 is equal to 4. So we're trying to solve for x. That is the goal. So notice what we need to do first is we need to get rid of everything outside of the radical. So we need to make sure there's nothing here, there's nothing here, and as we just have the radical before we can actually do anything to get rid of the radical. So notice we have this plus 2 at the end here. So we need to get rid of that first. So we're going to subtract 2 from both sides of the equation. So we have the square root of x plus 1 is equal to 4 minus 2, which gives us 2. So notice now we have nothing in front of the radical, nothing behind. So what do we do to get rid of our radical is we square both sides. So we square both sides. So squaring both sides, that gives us x plus 1 because our radical disappears, and 2 times 2 is 4. And then it's just a matter of solving for x. We'll subtract 1 from both sides. So x is equal to 3. And this is our answer. All right. So seems pretty easy enough. So if we look at our second example, we have the square root of x minus 15 is equal to 3 minus the square root x. Notice that we have x's on both sides of our equation, and we're trying to solve for x, so we need x on one side. So what we're going to do is we're going to get rid of this radical first. I know I said that we had to get rid of everything in front of and behind, but notice on this side right here, we only have the square root of x minus 15. So we need to do something so that we can work with this equation. So if we end up squaring both sides, notice if we square this left side, we're left with x minus 15. But notice here we have 3 minus the square root of x. So how can we rewrite this? So we have 3 minus the square root x times 3 minus the square root x. And we need to FOIL this out or factor this out. So what we're going to do is we have our first, so 3 times 3 gives us 9. 3 times a negative square root x is a negative 3 root x. And then negative root x times 3 is another negative 3 root x. And then we have root x times root x, which is just x. So this is really what we have on the left-hand side, or on the right-hand side. So we have x minus 15. And what we want to do next is maybe combine like terms. We're trying to get to a one single variable, or we just want one x. Sorry, that picture was annoying me. So what we have here is negative 3 root x, negative 3 root x. So we'll combine those because we can combine those because we have the same radicand. So we have x minus 15 is equal to 9. And if we have negative 3 root x's and negative 3 root x, we are left with a negative 6 root x. And we have plus x here. All right. So now it's just a matter of getting the x to the other side. All right, so notice, we're going to try to move all x's to one side. Let's say we're going to try to get all the x's to the left. So subtracting x from both sides, notice that these happen to cancel out. We no longer have just an x value. So we have negative 15 is equal to 9 minus 6 root x. All right, so notice we're down to one x variable, which is excellent. Notice our x is on the right-hand side. We can leave it there and we can just solve for x the other way. So the first thing we want to do is make sure we get rid of everything outside of the radical. So notice we have this plus 9 here. So we'll subtract 9. So we have negative 15 minus 9. That gives us a negative 24. And that's equal to a negative 6 root x. All right, let me extend the page here quick. All right, and then solving for x, notice we can't take the square root of both sides yet because we still have this negative 6 out in front. So we're going to divide by negative 6 to get rid of it. So negative 24 divided by negative 6, that's going to give us a positive 4 is equal to square root x. And the last thing we need to do is to get rid of that radical, so we'll square both sides. So 4 times 4 is equal to 16. And that's our answer. All right. All right, so if we move on to our next example, we have number 3. So we have, this one's not half as difficult as the one we just did, but we have the square root of x minus 2 minus 1 is equal to 5. Notice once again, we can't do any squaring until this negative 1 is gone because it's outside of the radical. So to get rid of this negative 1, we're going to add 1 to both sides. So we have the square root of x minus 2 is equal to 5 plus 1 is 6. And then now that we have our radical alone, now we can square both sides. All right, so squaring both sides, the radical disappears and we're left with x minus 2. 6 times 6 is 36. And then the last step to get the x alone, we're going to add 2. So x is equal to 36 plus 2, which is 38. All right, and then if we do just one more here, all right, this is where she hit it. We have 3 times 5n minus 1 to the 1/3 power minus 2 is equal to 0. This one looks like a large problem, but we can do this. Notice here, we have a 1/3 power. We also know that this means we're taking the cube root of something. So what we actually have and how we can rewrite this, we have 3 times the cube root of 5n minus 1, and then we have our minus 2 is equal to 0. So before we can do anything with this cube root, we need to get rid of what's outside first. So we're going to add 2 to both sides because we have a negative 2. So we're adding 2. So we have 3 times the cube root of 5n minus 1, and we have 0 plus 2 is 2. All right, from here, we're still trying to get rid of everything that's outside of the radical. So we're going to divide by 3 here so that these cancel out to 1. All right, extending the page. So what we have left is the cube root of 5n minus 1. This is equal to 2/3. And how do we get rid of the cube root? We take it to the 3rd power. We take both sides to the 3rd power. This ends up getting rid of the cube root. And so what we have left is 5n minus 1. And when we take the cube root, what we actually have is 2 to the 3rd, or take to the 3rd power, excuse me. So 2 to the 3rd, 3 to the 3rd. So what we actually have, 2 times 2 times 2 is 8. And 3 times 3 times 3 is 27. All right. So then from here, we're trying to solve for n, so we're going to add 1 to both sides. So we have, if I move over here, we have 8 over 27 plus 1. Well, we know when we add fractions or subtract fractions, we need that common denominator. So I'm going to create a common denominator on the right here by multiplying both the top and bottom by 27. So 1 times 27 is 27. So what we get here is 8 plus 27 is going to give us 35 all over 27. We keep the same denominator. So this is what's going to be on our right-hand side. So what we now actually have is 5n is equal to 35 over 7. And from here, our last step is just to divide both sides by 5. And what we're actually doing when we're dividing by 5, we're actually multiplying by 1/5 as well. So we can write this over here as 1 over 5. So if we do that, notice that we can do some reducing here. So if we reduce this, sorry, this should be a 27. I was kind of wondering why that looked weird. So the 5 will cancel out. This can go to 7. So what we have is 7 times 1 is 7, and 27 times this turns into a 1. So this is 7 over 27. And this is our answer. So not all answers are going to look super nice and as in whole integers. But I think that's where we're going to leave off. Please remember to go back to Schoology and take your quiz, and have a good night.